All right, welcome to our explainer on the critical methodologies for AI model validation. If you're an algorithmic auditor, well, you're in the right place. Think of this as your playbook for making sure the AI systems you oversee are effective, fair, and truly trustworthy. This one question is really at the absolute heart of AI model testing. It's not enough for a model to be accurate with the data it was trained on. The real test, the one that actually matters for business outcomes and for risk, is whether it can take what it's learned and apply it to new, unseen data. That right there is the huge difference between true learning and just simple memorization. Think about it. Auditing traditional software is pretty straightforward because it's deterministic. You put in X, you always get Y out. But AI systems, they're probabilistic. They make predictions based on patterns, not on hard-coded rules. This means the same input might not always give you the exact same output, and that right there demands a completely different and, frankly, a much more rigorous approach to auditing. So to build out this new audit approach, we've got to start with the basics. We're talking about two fundamental pillars, verification and validation. It is absolutely critical for an auditor to get the difference here, because these terms get thrown around and mixed up all the time, but telling them apart is essential for a proper assessment.
Okay, first step, verification. So what is it? Think of this as the technical check. It's all about asking, did the developers build this system according to the agreed-upon specs and design? You're just confirming that the as-built system actually matches the as-designed blueprint. It's a really crucial first gate in the whole audit process.
But here's the thing. Just verifying a model isn't enough, not even close. Validation asks a much, much bigger question. Does this correctly built model actually solve the business problem it was created for? It's all about effectiveness in the real world. A model can be perfectly verified, built exactly to spec, but still completely fail validation if it doesn't do what it was supposed to do. All right, now we get into the core diagnostic work for any algorithmic auditor, and that is assessing model fit. This is where you figure out if the model has truly learned the underlying patterns in the data, or if it's kind of gone off the rails in one of two classic ways. So here we see the two main ways a model's learning can fail. On one side, you've got underfitting. This is when the model is just too simple. It completely fails to capture the important patterns, so it performs poorly on both the training data and new test data. Then on the other side, you have overfitting. The model is too complex. It does an amazing job on the training data because it has basically memorized everything, including all the noise and errors. But the second it sees new data, it falls apart because it never learned the general rules. So if you're looking at a model and you suspect underfitting, your audit needs to verify that the development team has a process for investigating two key areas. First, is there a data issue? Maybe there isn't enough data or the data itself is just no good for training. And second, is it a model issue? Maybe the algorithm they picked is just way too simplistic to handle the complexity of the problem. And when it comes to overfitting, this quote just nails the auditor's role perfectly. Your job isn't to retrain the model yourself. No, it's to validate that the development team has a robust, documented process for finding and dealing with overfitting. You are auditing their controls, not redoing their data science. That's a key distinction. Okay, so let's imagine a scenario. A model passes all its initial tests. It's not underfit, it's not overfit. So you're done, right? Not at all. A model that is absolutely perfect today can become totally useless tomorrow. And this is the sneaky problem of model drift. Model drift happens because, well, the world doesn't stand still. Customer preferences change, economic conditions shift, new trends pop up. When the patterns in new, real-world data no longer match the patterns the model was originally trained on, its performance is going to degrade. It's inevitable. An unmonitored model is basically a ticking time bomb. So the big question is, how do you audit for model drift? Well, a really powerful control is the Model Card Revalidation process. Think of it like a periodic health check for your model. Here's how it works. First, an independent team gets the deployed model. Then, they test it against a brand new holdout dataset it has never seen before. Next, they compare the new performance numbers against the original benchmarks from the model card. And finally, if performance is dropped, the card gets updated and reissued. It's a concrete process to make sure a model's documented accuracy reflects its current reality. Okay, so we've covered performance and longevity, but a truly comprehensive AI audit doesn't stop there. We have to expand our toolkit into two other absolutely vital areas, making sure the model is fair to all groups and that it's resilient against attack. So to test for fairness, auditors use hard numbers, quantitative metrics. to look for something called disparate impact. That's just a term for when a model might be accurate overall, but performs way worse for a specific group. For example, demographic parity checks if outcomes are equal across groups. Equalized odds checks if the error rates are the same, and disparate impact is often measured with the 4/5 rule. This is a key guideline where a model gets flagged if the selection rate for a protected group is less than 80% of the rate for the highest selected group. And then, to test for resilience, we have adversarial testing. This is basically a controlled stress test. You're intentionally feeding the model weird, unexpected, or even malicious inputs that are designed to trick it. The whole goal is to find the vulnerabilities and breaking points before a bad actor does. It's all about making sure the model is robust enough for the real world. So, after all that, what is the single most important takeaway here? It's this: auditing an AI is not a one-and-done pre-launch event. If you want to build and maintain trust, it has to be a continuous cycle of governance, monitoring, and oversight. And this structured process flow shows you exactly what that looks like in practice. It all starts with scoping, moves through data collection, model assessment, bias testing, and goes all the way to reporting and ongoing remediation monitoring. You see how each stage builds on the last? It creates this comprehensive framework that turns a black box into a governable asset. And that leaves us with a final and I think crucial question for the future. As these AI systems get more and more autonomous, as they make more decisions without a human in the loop, the job of an auditor fundamentally changes. It becomes less about verifying lines of code and much more about validating something far more complex: our trust in the system itself. How we answer that question, well, that's going to define the future of the profession.